There we go.
Okay, well, this is, well, why is my camera in such a weird state? Okay, I'm also weirdly backlit. That's okay. This is lesson 21 from Practical Deep Learning for Coders. We're supposed to be talking about, what was the advertised topic? Let's see if we can.
DDIM, I think.
DDIM, right? So that is part of this, surprisingly. Not too surprisingly, maybe, but
It's
sometimes
interesting.
it's.
I feel like that's the part I didn't focus on really that much. I kind of ran out of time and like I missed like the last 10 minutes of the video and they
No
were talking about
worries.
the paper. Um, but yeah,
Well, it was done kind of fast.
yes.
Oh, there's my cat meowing. Sorry, I'm just trying to find my Zoom window now. It's got away from me. Um, hmm. That must be the small. Nope, that's even smaller. There we go. I mostly use Teams, so whenever I have to use Zoom, I always get a little thrown off.
Yeah, me too. We recently just kind of converted to using Teams full time, got rid of Zoom.
Yeah. Okay, so hopefully you can see my window where I've zoomed in
Yep.
somewhat.
Yep. I can see
Lesson
it just fine.
21. Maxwell, shut up. Sorry. To all of the people listening, that's my cat being crazy. Um, so the first part of this lesson, they start out with a little demonstration of the weights and balances website, which is called
Yeah.
wmb.com, which allows you to send, basically you can write functions. You can, if you use this library, you can send functions to weights and balances website and it'll log all the things for you. And then you can go on there and view them on there. I watched it, but I didn't try to reproduce any of that. It's in the video. The other key thing there was he
Yeah.
did demonstrate kind of coolly use CFAR 10 images instead of the fascia MNIST. He hardly had to make any changes to the code, which is pretty cool.
Right. Yeah. Yeah, I thought the weights and biases tool looked pretty neat, like how much stuff it can actually track. And I think couldn't it save your models out there too?
Yeah, I said you can put models, hyperdata, your Jupyter notebooks. I think anything you can probably say anything up
Yeah.
on there
So fully
for saving.
reproducible.
Right, that was their point, right? It's a fully reproducible environment.
Yeah.
So Jono implemented a callback for that in a few lines of code to implement that to set, so illustrating the power of the callbacks is pretty cool, I think. Um, and then at the end, Jeremy says, "I don't use this." That's kind of funny.
Right. Yeah.
It's like that's cool, but I don't use that because I just worry about doing. I don't want to spend my time doing broad, wide sweeps of all the hyperparameters and try to think about what things I'm looking at, and everything. That makes sense, but you can do both. You can do focus search and still
Yeah.
have use that tool
Yeah,
if
I
you want
agree,
to.
but I
Or
feel like that's a common refrain with Jeremy because I feel like way early on he likes using intuition, right? As
yeah,
opposed to
no, it's that
just
wasn't surprised, but I wasn't surprised by
yeah.
that. I mean, neither was
Yeah.
Jono. He knew that, so he let him demonstrate it anyway.
Yes, he did.
So the next topic, the key topic was this image quality metric, which this was not the advertised topic, right? He said the advertised topic for this was going to
Yeah.
be UNet, so but he decided no, we got to step back a little bit. So the first thing he realized we don't have a need is some way to numerically evaluate these images. Like we have two different models to generate images, which one's better? I mean, you can try using your eyeballs, but it becomes difficult. And so he talked about this one. I think I misspelled this, not Freche. Is it Freche? I think there's some accent
Close
graves
enough.
and stuff.
Weren't they saying Fid and Kid?
Yeah,
So
they were just calling it the FID thing. So this demonstration was done in 18 FID iPad and notebook, Jupyter notebook at the
yeah.
repo. And this is apparently a commonly used metric for evaluating image generating models. And it's a measure, some kind of measure of how similar statistically similar in some sense, your generated images are to the real images you use as the training software, training models, right? Training images. I keep throwing weird words in there. So specifically, it takes a look at the statistical properties of the final layer of activations from a neural network trained on classification, right? That's what it does. So
Yeah. So
because the
just
class,
on that point, real quick, weren't they also pulling back a couple layers and cut some of their examples, so it wasn't
the
always.
only thing they really call it, when I say final, I mean the activations before they then turn into a softmax type thing. So
Oh yeah, yeah, for the true
yeah,
classification.
right.
So
So
it was
you rip
right
off
before.
the it doesn't I should have said that you rip off the final head, and that's exactly what he does. So
Yeah.
this
Yeah. Yeah.
import all my stuff here. Nothing really interesting here. but now we got to pull in our classifier. So this is just some things that the classifier expects to have defined. So he does that. I did change the batch size for when I ran this code to 256 from 512, just so I could only really do my models on 256 without running extraordinarily long. Even with my GPU, I couldn't do the speed that Jeremy was able to get on his thing. Well, first it was really taking an extra long time. I don't know why. I'm like, this doesn't make any sense. And I realized I'd filled up my GPU memory while experimenting, so I took advantage of that clear mem thing that he introduced.
Yeah, that's what I was thinking.
And that helped a lot, but I still like maybe factor 3 slower than him for some reason. I don't know why. Maybe just, my GPU or whatever.
Yeah.
I have no idea.
Okay.
I don't know. I don't know what his hardware looks like. Maybe he's got multiple GPUs. I have no idea. He probably does. I mean, why not, right? Makes me think I need to set up a even better machine learning. I keep going back and forth on this because, like, for a while, a lot of my work was in this is kind of a tangent, but hey, whatever.
No, you're good.
My work was focused on statistical analysis, inference, and all this kind of thing, right? But now I'm doing inference on really complicated models, and I'm having to go back and now it turns out the state-of-the-art way to do this is this thing called like normalizing flows, which of course is a neural network. And now I'm back to like, oh, I now need GPUs to get to train these neural networks.
Yeah, you do.
Actually, normalizing flows are another kind of generative process, just like this DDIM, and they're also used for generating images. So all ties together. It's kind of interesting.
Yeah. Oh, how about that?
Maybe if we have time, I can do a quick presentation toward the end of this thing on normalizing flows. Might be fun. If I get that far. Actually, I was going to play with that this weekend a little bit more, normalizing flows in the abstract, not for my problem. Anyway, so what was I doing? Okay, so this is all stuff we have to set up for loading the model. But in the end, I saved one of the early classification models. I did not the same one he did. He had like DataOg 2. I don't know if he did something special versus DataOg 1. I forget. I didn't reproduce it for whatever reason. So this is the model I'm using for this. So I have been getting different results than he got. That's probably why. Also, they're somewhat random. There's a lot of fluctuations in these scores. So as he said, there's so that's all this does. I'm not going to belabor it. All kinds of errors about don't use pickle anymore. So this could have malicious. It's true about pickle, but anyway. So here's the model, right? So the cool thing about Python, people implement these dunder methods, and then you can type the name of the object, and it'll just spit out some kind of representation.
Get you all the layers there.
Sometimes useful. In this case, it is useful. We can see, oh, there's all these layers. Well, now it's truncated, so I guess you can't see all the layers. I don't know if I can reproduce it now. Batch normalization. Well, I was able to see all the layers. You can see at the end there is a. Do I dare try this? Oh no, I guess that is the last layer. I thought there's more. Did I rip the bottom off already? Res block. This is the one we want, though. This layer right here, I think. The activation after this. So this, I think, is what we really want. Well, no, we want to flatten. So this is the one we really want. So then, okay, this makes sense.
Right? Getting rid of 7 and 8.
Right. So here we have 512 features, and the next layer maps those down to 10, which eventually go into soft. I was looking for the softmax, but it's not in here. Of course, that's always done because we're using that cross entropy loss. It already does the softmax for you. So the point is, we want right before this mapping from 512 down to 10 classes. So that's why ripping off these last two is the right thing. Make sense?
Yeah, I'm following.
Yeah. And so I didn't bother with doing it the complicated way with the hooks. I just did the easy way by just deleting them.
Yeah.
Right? Why make it harder on yourself? I forget the purpose of this. This is just to make sure that the model's doing the right thing. We expect to get 512 things back, and we do. Great. Okay. Fleche inception. Oh, the reason why it's called inception distance is because the original paper used the inception model, not whatever model we're using, classification model. But we're using a model that's actually trained to classify fashion MNIST, so it should be very well suited to this, right? So we should call it the Fleche MNIST. What do you call it? He was trying to think of something else I could stand for. I forget what it was. I forget now.
Yeah, he was trying to make a joke or something about that.
About that, yeah. But anyway, it's not really the inception distance, but it's the same formula. So this is the formula for the distance function, but it's basically just the average, the mean, right? The difference in the mean, the L2 difference in the means, and then this complicated formula, which is the trace, the covariance of the one and the covariance the other, plus 2 times the square root. Why this formula? I don't know, but that's what we're using to compare the
Yeah,
compare.
yeah. So it's means and covariances are kind of important.
Right. Yeah. And he
All right.
made a point of the fact that this we require the square root of a matrix. So he had a little diversion about how to do the square root of a matrix, which I'm going to kind of skip over because it's just a mathematical detail, and PyTorch has built-in things for doing square roots
Yeah,
of
for
matrices.
sure.
I don't think they use that method he defined either. I think you can use, it's much better to use eigenvalues to do, but I don't know, whatever. He defined a method that basically is like a Newton-Raphson generalization, but for matrices, right?
Yeah, that's right. He went on kind of an aside there. It was still pretty hand
Let's
wavy.
see. All right, so fine. What is this about? Okay, now we need to get our image generator in. So this is the same kind of thing again. I changed this, by the way, to 0.01 because I found out that all the things work better with, because later in the talk, he's using 0.01 for the final beta. And earlier in the thing, he was using 0.02, and I couldn't match his results until I changed 0.01 to be earlier too. It made a big difference
That's
taking beta
interesting.
all the way to 0.01. And I apologize, I didn't really have a chance because I just found this out yesterday to dig into like why that makes such a big difference. But like I was getting like 40 for my fit scores. I changed to 0.01 and I got 8. So whatever that means, it was a big difference.
It's interesting.
uh,
We're calling that Betamax.
yeah.
Betamax is superior to VHS.
Exactly. Yep. Everybody talks about that because it's like a typical example of how first mover advantage, can beat technological superiority all day long. Anyway, so this is just redefining things we defined before. Um, don't know if we even need this noisify function. I don't know why we brought that in.
Yeah, I feel like we defined that multiple times. Uh, but
Not sure we need that. Why is this? Okay. The end result is we need this UNet model,
mhm.
which is just the wrapping of the UNet 2D model, but with this taking the forward function and then adding sample on the end. Later, we're going to stop doing that because the the libraries in Diffuser's library does this for you and doesn't want this part done. So he will later redefine this to just be pass to do nothing. It's just the same class, it's a different name. But you need to load in one of the just important thing. The point is you need to have the class loaded before you can load in the model. Otherwise, Pickle won't know what to do with it. I don't know what error it gives you, but it won't work basically. I think I'll just say, hey, UNet not defined or something like that when it loads it in. If I remember correctly, I've done that before in the past,
Okay,
or I've forgotten to. I don't know why
gotcha.
that's not scrolling properly. Who cares? Um, well, one of the things I did, so he has this. Remember, he was saying in the thing, "Oh, this is so complicated. Like the new version, the DDIM is so much simpler." Well, it's because you were doing this wacky multi thing again instead of just the simple thing. Algorithm 2 in the paper, right? And the DDPM paper is also pretty
Yeah.
simple. It's not that complicated. It doesn't require all these variables. All these variables I'm not even using in here. I just define them that because you have to, right? So yeah, so that I actually tried both because I thought maybe there was something wrong with my version, but it didn't matter. So this is my version of the sampling
Yeah,
function, the
yeah, it's
denoisifier.
definitely simpler there.
Yeah. And this is just algorithm 2 though, from the paper.
Okay.
I brought that up back when we were talking about DDPM.
Yeah, I
So
remember that.
yeah, so this is for me, this is I guess a factor of 4. So this right here, I sampled this model, 256 of them, right? And this took me 2 minutes and 9 seconds. In the video, his system he does in 34 seconds. I'm like, did you run any of these things? Did you?
I didn't run this week, no.
So it was kind of difficult for me to figure out why. It was actually taking more like 20 minutes until I found out about that memory problem I was having. So that makes
Yeah.
a big difference. It'll keep trying, I guess, even though the memory's full. I don't know. I think I heard the fan quiet down, so I think it diverts back to the CPU. I can tell when it's working because over here my phone goes while it's doing it for 2 minutes. And I can tell when it's done because it goes, oh, it must be done. So it's like making coffee over there or something. Like the coffee's
That's
done.
funny.
Yeah.
Yeah.
Any event, here's my generated images. I don't know. I guess they're similar to what he was showing.
Yeah, they're not bad.
One difference too is I don't this is sampling, right? So training was where I was really seeing the problem, not sampling. Sampling was still slow. Retraining was where I was really seeing the problem. And I retrained this model because I had to retrain it to put in the fix that he talks about in a minute. So that took even longer. But I didn't train, this model is not, the point I was trying to make is this model that I'm using here, that I loaded in, is not trained for as many epochs as his. Actually, let me just see what this one right here, because I didn't, reason why, because I didn't do lesson 20. That's what it was. I didn't do the lesson 20 work when we did lesson 20, when you did it, I think.
Hmm. Yeah.
I didn't actually go through and do the mixed precision thing and try training in there. I had to go pull that in. And so I did the training on here. How long did it take? Still on there? No, the timing's gone. I guess it is. When you first run it, it'll tell you. But anyway, I only did 10 epochs, so there's no way I'm going to do 25 epochs at how fast this was going.
Yeah, I remember some of this stuff taking a while. That's where I was
Yeah.
putting the ice packs underneath my
Yeah, you told me that.
laptop
That's
because
right.
it was getting
I
so hot.
remember that. Exactly. So I did it only this much, 10 epochs. That's as brave as I got. I didn't want anything to happen beyond that. But everything ran, nothing shut down. Computer didn't hang or anything. Some of the models I've been working on, trying to do ABC sampling for posterior sampling, approximate Bayesian computation on, have crashed my computer, and that's just CPU intensive, not
Yeah.
GPU intensive.
Okay.
Because it tries to use all my
Huh.
cores, and one of my software programs tries to update at that point, and then the whole computer like freezes up.
Isn't that something you can like limit the number of workers, right?
You can. That's why I didn't do that. I just did the default, and I learned my lesson that way. Yeah.
Yeah, yeah, yeah.
Okay. So anyway, I
Okay.
digressed on that a little bit.
That's right.
So he takes all. So there. These are the images we want to evaluate, and so we're going to put all this into a class that he likes to do. So all the things he talked about, I skipped all that. I'm just going to put it right in a class, right? All at once.
Hmm.
Since the video does the duty of telling you all about how these things work. He also quickly introduced this kid kernel inception distance, and basically what I got of that is he says the math doesn't matter. Here it is. Is all I got.
Yeah, the high
It's
variance thing, I didn't really focus on that too much, but he was kind of worried about that statistic. It's kind of like, with these different runs, you could get drastically different
yeah.
values. So he
So
was
that's
kind
just
of
saying,
nervous about using this in the real world.
yeah. But he said it had low bias. Like if I remember, I think that was with respect to like the size of the data sets and that kind of thing. Is that what it was about? I wasn't sure. Or was it about having small samples gives you, usually bias has to do with sample size. Right? You have small samples, doesn't match the mean you get for large samples, but I'm not sure. I'm not sure exactly what he meant by bias.
It
But it
just seemed
did,
like it was an unstable metric,
yeah,
right?
yeah,
So, that kind of worried me a little bit. But then the examples he was showing, he was basically getting the same result. Uh,
yeah.
I mean, not the numbers because they're on different scales, but like he did that thing with the plots
Yeah,
over time and
yeah.
kind of how they went down or whatever, and it's like the same shape regardless of whether you
That's
use
right.
the
That's
fit
right.
or
So
the
it didn't
kit.
seem like we were seeing that the high variance thing he was talking about. But
Yeah.
in any event, this is these are some helper functions that are going to be used in the class. This does nothing but calculate the statistics of the last layer, right? The mean and the covariances. And then this over the axis 0, I think that's what that means, right?
Yeah, I
And
think so.
and then this function actually calculates the fib from that. And here we can see you're taking the difference of means,
You have to trace all that stuff.
traces of
Yeah.
that, and the traces of CSR, which is just the square root of the multiplied together matrices. And we're not using that function he made, we're just using this linear algebra function from was it from SciPy? I thought it was from
PyTorch or something.
I thought it was from PyTorch. Am I using the wrong one? Ah, whatever. I was gonna try to dig for the import, but oh no, yeah, it is from SciPy. I misspoke. So it's the SciPy's linear algebra thing. I shouldn't have done all the scrolling. I'm lost. Here we are. And then I didn't really dig into trying to understand what's going on here, to tell you the truth. So if you have questions about that, good luck. No.
It's all right. Yeah. That's
I only have
okay.
so much bandwidth. So that was outside of my bandwidth. Did you have the same experience? I'm like, I'm just not gonna. I could sit here and try to
There's
figure.
just so many topics in a given
Yeah,
lesson
they
that
just jump around. Yeah, I know.
you can't take in all of them in depth.
So let me just put it this way. What I learned from this is I kind of understand what Fid's doing, and I'm aware that kid exists. And it's a different option.
Yeah.
This is what I understood from
But
that.
if I had to choose one, it wouldn't be kid, even though
No,
the math is maybe a little easier, right?
I guess. I don't know.
I
How
mean,
you
that's how
always,
they kind of positioned it.
yeah. In any event, he defines this class that takes in the pre-trained model, classifier model with eds, with the ends, so the head stripped off, as they call it,
Yeah.
and captures the whatever the captures the predictions on that, grabs the last layer, squeezes it out, and then calculates the stats on it. That's basically what it does for a batch. All that is fine. In the end, you just call it. You just create an instance of it with the model you want to use, and just call it with your. This learn DLS, by the way, is how it's getting the other one to compare with, right? The data learner, the data loaders for the training batch that was used to train this classification model.
Right.
Or maybe it's the other one. I'm not sure, but they're the same, so maybe it doesn't matter. And so I made sure the batch size the same. So this is about the kind of results he was getting. Actually, the reason why it says only 8 because I was getting bigger numbers here, but that's why I'll make all these excuses here. But turns out the changing beta max to 0.01 instead of 0.02 made a big difference and brought this down more close to what he was getting. In fact, it's a little bit lower than the self thing, which I don't understand how that could be. Like, okay, whatever. Maybe my XB is defined badly or something.
Okay. Huh.
Not worried about that. So at this point, he makes a little digression into the scaling bug. This was kind of entertaining. Maybe I can get rid of this. I don't need this. Okay. This was kind of entertaining because he's like, well, I'm scaling these. I'm not bothering to scale these things from -1 to 1, which what you're supposed to do, right? For whatever reason, that's what everybody does, quote unquote. So he fixed that, but that didn't made everything worse. So he said 2 days, and hey, we've all been there. We've all been there trying to track down this bug. The other
Yeah.
bug, the
He
offset
went
bug.
down the rabbit hole.
Yeah. So then he said, wait, why do we scale? Why is it a bug to scale from 0 to 1? So he tried instead just subtracting 0.5 and everything, and that keeps the range the same, 1, but centered it on 0, and that seemed to work a lot better for everything. That was an improvement to the model. So I did go back. Actually, I think this is the way the models already are that I was training because he had fixed the code by then, right? So this bug didn't exist when we're doing it. It only exists in the videos. But I did go rerun the models because I didn't. The reason I rerun the models because I didn't do the fixed precision thing. That was the reason why. So now he talks about skip sampling, which I kind of skipped it because I thought it was a bit ad hoc. He's just like, oh, I'm just going to skip time and see what happens. Like, okay. But I mean, the whole one of the purposes I thought the DDIM was allow us to do skipping, and with the implicit sampling was going to make the skipping better. But to be honest, I should have done this. Now I think about because I'd like to have compared how the skipping with the DDIM compares to the skipping with the DDPM, and I didn't really do that. And I'm not
Is
really
this the part where he
satisfied.
was uh like redoing the model after so many epochs or whatever, like every 3 or
No, it's where he was like, as when he's sampling, right? He instead of just he just skipped time steps, like go from t equals 1 to t equals 10 to t equals 20, right? And
Oh, okay.
denoise by
Okay.
bigger chunks,
Yeah.
right? Which you
Yeah,
can
yeah.
do, right? Because you can do that because we have the formula that tells you how to do that. So it just doesn't work as well, but it's faster. But I thought the reason for introducing the DDIM is to make that skipping better. And I didn't never really establish that that's actually the case in my study. So is the cleaning the memory, right? Important thing to do if you want to do more
Yeah,
work on your
for sure.
GPU. Actually, I mostly had my little monitor up there that shows me what the GPUs do so I can see it fill up the RAM, which I do quite often. That's another reason to use smaller batch sizes. Let's see, we could skip a lot of this is just rebuilding things because this is like a new notebook. Did I say that? Yeah, this is notebook 20. So what I do is when I'm thinking, write my notes, I do it all for the whole lesson in one notebook, but I make notes. Oh,
Sure.
I can start here now if I want to run
Yeah.
things
Yeah.
because I just re-import everything all over again, including the model, which we'll do here. But here's again where he now is not going to do the forward, call the forward method and then call sample because the library schedulers from the diffusers library doesn't want that, it's going to do that for you. It's just one of those things you just have to know or discover by looking at error messages. How I usually discover these things. So once again, we load our model, listen to the warnings about malicious pickles. Sounds like a good name for a band.
I like it.
Malicious pickles. Anyway, um, so we load in a schedule. So now we're going to instantiate one of the DDPM scheduler from Hugging Face's diffusers library. And I think this is more or less, if you pick, you can see the defaults listed here, right? The only thing a little strange is this time step spacing. It says string equals leading. I tried to look into what that, does that do something different? I couldn't find out. Didn't have enough time to really dig into it enough to find out what it does. One of the reasons why, because this worked a lot better. So here's my low, not 2 days, but a couple hours process. Like, why, when I ran this, did I get like an 8? When I ran the previous DDPM up above, right, I got like 42 or something. And so I'm thinking, well, maybe this DDPM thing does something clever. So I started digging in that. But it turns out it was just this.
It was just the beta.
I guess I should try I didn't do the obvious experiment, which putting beta 8.02 and see this go bad. I should probably do that, but who has time for that? Anyway, the notebook uses, again, 2048. I want to do these things faster, so I just use 256. That's another difference here. So using this thing is pretty easy, it turns out. You instantiate it, and you just call step on it. Boom, you're done. You got to put it on the loop. You can add a progress bar so you can see things work. It all works fine. In fact, maybe I could define all this stuff because, I won't bother. It's really fast. Well, it's fast. No, sorry, this isn't fast. This is 2 minutes. Not doing skipping yet. This is 2 minutes, but keep that in mind. This is 2 minutes. The same 2 minutes it took me before, so it's not any faster because not doing anything presumably different. The images look basically the same, goofy, weird,
pretty much the same.
And then now we have to load in the classifier again, right? And then blah blah blah. Evaluate it. Oh, it is actually a little bit better, like that's, but I don't know if I didn't repeatedly do with different seeds. I don't know what the standard deviation of this is.
Yeah, exactly. Do you get a lucky bounce?
I see it fluctuate by ones, plus or minus one. So I think it's pretty bouncy. Because I did run through this many times. Here's my user caveats of why things are different. And again, I've seen this weird result where the real images are worse on this score.
Yeah.
So that's maybe something wrong with this XB. I gotta look into that. I won't.
That does not make intuitive sense.
Yeah. I suspect there's something different about this XB, but it's not important. I mean, to me, it's not important to me. We're real on time. It could just be the fluctuation thing, but I don't have time. I will look into it, I think, because I think it might just be the fluctuation. That's twice now, and that's 2 samples. That makes me worried now. Yeah, weird. I want to look at the shape of these things, and I have to load them in and generate them to make sure they're really the same size. I wonder if these are different sizes. I messed something up that way. You know what? I'll run it while we're talking. Is that all right? Yeah.
Go for it.
Let's clear the memory here real quick. Import all this. This probably will break now. Load the data set. Load the model. Define the model. Get warned about pickles. Define the scheduler. Compare the size. This will take 2 minutes, so we'll let that go for a while and continue on. Okay, so the next thing he did is use diffusers library also has a built-in DDIM. So if you don't want to write your own, you can just use theirs. Has all kinds of options as well that I didn't really dig into, but I guess the defaults are good enough. Just have to define beta. And but there is, I'm sorry, I want to point out one thing. Where is it? Where's Ada? Oh, I think Ada is 0 in this thing. So I'm pretty sure in this DDIM schedule, it has Ada equal to 0. I don't know if you follow this part of the paper or not, but we'll get to it. I'll talk about it in a minute, but just keep that in the back of your mind. So I ran, oh no, you can. Oh, I guess in the step you can tell what ADA is. So you can say what ADA is. So what I found weird is that every time they do this, they put
Hmm.
ADA equal to 1, which when I read the paper, ADA equals 1 is supposed to be the same as DDPM. So that's a point of confusion there, and it does give similar results. Fidelity, actually, the score was a little bit higher. But again, I think this is maybe just fluctuations in this score. It's hard to say whether this is actually worse or not, but I'm sorry, I'm skipping here though. So it should be a little worse. Yeah, I'm skipping 10, sorry. So we're skipping every 10. So we're doing 1/10 as many samples on this one.
Sure.
So
Yeah.
it does make sense that it's worse than before. But I think this is just skipping on DDPM. I don't think this is DDIM at all.
Yeah. So I didn't go too deep on what this core lecture was supposed to be about is DDIM. Like,
Yeah.
what are really the benefits of DDIM versus DDPM? I mean, it seems like DDPM's a special case of DDIM. Is that right? Because you're saying if you set eta equal
Yeah,
to
it
one.
is. So I'll do, so still about 11 on there. Oh no, so now it's 11. So this is when it was 8 before. Now it's 11. I just ran.
That's yeah,
That gives you an idea of the fluctuations.
that's some serious bounce
And now this
going
is
on there.
9. So you know what I'm saying? So there's some serious balance. Well, probably because I'm only using sample sets of 256. He's using
Yeah.
2048, right? I don't have the
Yeah.
patience for that because it took me 2
Right.
minutes to sample those. That's going to take, 4 times longer, right? Wait, 10 times longer. So forget that. Right? 8 times longer, really. But yeah, you get
Right.
the
Yeah.
8 times
Yeah.
longer. So I don't have that time. I don't want to spend that time
I get
wasting
it.
on that. So that's one of the things happening. Okay, so it's just fluctuations. And we're saying that he doesn't see because he has much more averaging or much more images. Okay, so that's fine. We resolve that. And then doing it with this one is, screams. I mean, it's like 12 seconds. It's very nice, right? Because we're skipping every 10. Makes sense, right? 10 times less time. So I could have increased there to 248 probably. 2048, sorry.
Yeah, because that's pretty quick.
And yeah, so it's comparable. It's
That
actually,
one's
so
about the
this is
same.
interesting. So this is not that much worse, but there's a lot of fluctuation. I don't know if it's worse or better, to tell you the truth. That's one of the reasons why he uses so many samples now, because he could do better comparisons. My noise is too big. I can't say whether that's a significant difference or not. It's not, in fact, I'm pretty sure it's not a significant difference, but they're comparable, at least similar, right? And I'm
Yeah.
skipping every 10. That's pretty amazing, right? You don't need to do that many. But I still think this is actually DDPM and not DDIM. Okay, so back to what is DDIM. So we define the linear scheduler again. This is just a little side work here. So if you remember from when I talked about DDPM, they derived from the forward process an expression for this conditional probability of what is the image at x of t minus 1, given, so remember we go from x of t is the completely noised image all the way to x0 is the actual image, right? So if I know the image, right, I already have an image, and I know what it was like at x of t, I can write down a conditional probability of what x of t minus 1 can be, right? What kind of, that's conditional on that. You can just use Bayes' rule and work it all out, and that's what they do. It's actually
Yeah.
not simple, but they do work it on that appendix to the DDPM paper. Okay.
Hmm.
And then they use this and with the KL divergence to try to figure out what the training loss should be to train the model to predict the noise. Okay. That's what they use. And that's a nutshell of DDPM. Now in DDIM, they say, hey, we can take this step, this function here, and then generalize it, right? This is that same step, by the way, just written out. Well, no, this is
Hmm.
the DDIM step. Generalize it so that we can add different amounts of noise than what that one does. And if we do it in the right way, if you marginalize out the x of t, I should get the same total forward step, total reverse step that the total forward step. Forward means adding noise. I keep that straight in my head. The same forward step from the whole step from from the image at 0 to the image at t, whatever T you want to choose, right? Remember in DDPM, there's a closed form for that. You don't have to take all the steps one at a time. There's a closed form, it's just normally distributed. And you can add all the noise at once, right? And so if you add all the noise at once, you get the same answer with this more generalized function,
Mm-hmm.
but the individual steps are different. So that was the idea. So if that's the case, then you can use the same loss function in training. But we can now investigate what the effect of changing this noise is, this sigma is from what it was fixed at for DDPM. In fact, they use this function to parameterize the noise. So eta is kind of like the parameterized noise. The reason I did this way, you say eta equals 1, they say, and you put all that in there, you get the exact same expression that you had in DDPM. That's what I got out of the paper. Right. So when they're using eta equals 1, it doesn't make any sense to me. And eta equals 0, it's supposed to be true DDIM, truly the implicit model where there's no noise at all added during the denoising process. Remember, in the denoising process, you have to add noise. But with this, there's a way to do it. You don't add any noise.
Yeah.
If you don't add any noise, it makes sense that you can take bigger steps without any problem because it's completely defined, right? So that's what I got out of that paper. I'm not sure if that's
How old was the DDIM paper? Do we know when that came out?
Let's just take a quick look here.
Just curious.
2020. So
Fairly recent, and that
we're
came
learning
out
state-of-the-art
after.
stuff, man. I'm telling you what.
Yeah.
Kind of nice, huh? Yeah. But yeah. So
Good.
2020. But I mean, I read most of it, but I didn't follow all the math. I definitely didn't read that long. The way these papers work nowadays, people write a paper that's like 20 pages, and they have 20 more pages of appendix, right?
Yeah.
And this is no different in that case.
Mm-hmm.
And the appendix is written in a much more tertiary style because it's just kind of like for their own records, I guess. I don't know. That being silly, but I'm sure if you spent some time studying it, you could figure it out. But it does take time. Anyway, so in the end, this is the formula that they use for the step function. So and this tau is not t; it's actually whatever schedule you want to use of times, right? So there's 100 of them. It'd be skip 10, whatever tau. The tau is that subset. So tau could be 0, 10, 20, 30, 40, right?
Yeah.
That's all that means. But the key thing was this eta variable. And again, I gotta say, I didn't completely. I said anyone. If you had any ideas like why, for example, why Jeremy used 8 equals 1 when the paper says 8 equals 1 is DDPM, I'd love to know that.
I feel like I again
literally says this includes the
sped through
original
this last
DDPM
part.
process. Yeah.
Okay.
So anyway, that's a mystery to me. So I write up the DD. Oh, did I?
Is there a forum for the part 2? The
There
fast
is
AI.
there is a forum. Yeah, every episode has a link discuss this episode here, and I went there and I didn't see.
No one asked about it.
No one seemed to be questioning that. And I was going to add something like, it's like everything's 2 years ago, so I'm not going to resurrect that. Necro the forum, as they call it, right? So I didn't, but I could have, I guess. And you know what? The other thing is, it might come up like next week. Who knows? Somewhere you go, hey, by the way, last week that's happened already 14 times, so I wouldn't be surprised at least.
Well, there's still interest in this course. It looks like even in the data science learning community, there's a interest in doing another cohort of this.
Yeah.
So that's pretty cool.
Yeah, for sure. So I coded up the step here. I already evaluated that. I did. And what he did for whatever reason is he decided to find, I don't know if this gets exported or not because I didn't copy that over, a more general sample thing that will take in whatever step function you want to use. F, I guess, is what that is, right? So it's just the same sample function before, but now where you calculate the x of t, we just call F to do all the work for us. So again, 12 seconds instead of 2 minutes, the same as we did before with the, in fact, I think the results are similar. Yeah, they're similar. You can see right there. To when we use the DDIM from the diffuser library. And I didn't bother printing out here I said a bit worse, but I think now I realize this is all fluctuations and not actually worse. I even said that, but this
Yeah.
fluctuates a bit.
Yeah.
So, I did look at the images. So here they are. What is that? I have no idea.
Kind of looks like a backpack
Maybe that is what it, but maybe it's merging between a
or a
backpack
shirt or something in
backpack and a
between.
shirt. Yeah. At least they're recognizable for the most part.
Yeah, I agree.
So just for fun, I said, okay, well, let's try 80 equals 0, right? Instead, which is supposed to be the true DDIM. And of course, I really couldn't tell any difference. Now I know why, because I started thinking about the fact I hadn't thought about the fact that I was using such smaller number of samples is the real bugaboo here, right? So I can't really tell, this in this particular instance, it was a little bit worse. Okay, but now I know that the fluctuation is about 5, so whatever. I think that's it. Yeah. So 8 equals 0 didn't seem, at least in the small sample size I'm using, to be
Didn't
significantly
really do
better
much.
than 8 equals 1. So
Hmm.
that's a little disheartening. Maybe if I skip more, I don't know. I just don't know.
You just got to do it a bunch more times, right?
Yeah,
Get those
or
standard
use a bigger.
deviations.
All right. I mean, I could certainly increase the batch sizes and everything now that it only takes 10 seconds, right? So, but I won't probably do that because I got other things to do.
We all do. You got the other course you're doing too.
Yeah, Rust. We're
Yeah.
off for the next week, I think, though.
Yeah. Same with the other thing I'm doing too.
Yeah, we're off on this next week, right? Too.
Yeah, I think we got 2 weeks off. Do you want me to hit end?
Yeah, go ahead.